So welcome to the third slot. Our next speaker is Franz Thoma, who's a principal consultant at TNG, located here in Munich. He has been shaping software projects for over 10 years now, both in the roles of product owner and software engineer. Franz is an expert in designing efficient software architectures, accompanying products to success, and building up flourishing organizations. He's also enthusiastic about functional programming, especially Haskell, domain-specific languages, and tinkering around with compilers. I'm glad to have you here as a speaker. The stage is now yours.
Yeah, thank you very much. So, Factorio is a game that tickles all the right brain cells for a software developer. It has very simple ingredients, but very high complexity, lots of potential for optimization, and the game is in fact powerful enough so that you can build a proper CPU in it. But the more surprising part that I found is that this game is not only captivating to play, but you can also learn a lot from playing it about software development and software architecture. By the way, when I say captivating, I really mean addictive. You may spend hundreds of hours playing it, so don't say I haven't warned you. Before we dive into the main topic, let's have a very quick introduction to what Factorio is about. Like any good game, or at least in my opinion, the background story is very short and becomes irrelevant very soon as it is replaced by game mechanics. So the background story is we are stranded on a foreign planet and we have nothing but an axe. Our objective is to build a spaceship in order to get home. Now, building a spaceship from scratch with nothing but an axe is a hard task, right? So we need to automate things on the way. Most of the time, we are not going to build rockets or rocket parts, but we will build machines that produce rocket parts, or even machines that produce machines in order to produce rocket parts, and so on. And after that, after we've reached that goal of launching our rocket, why stop there? Building a spaceship is just the beginning, and Factorio allows us to continue playing. And as we are building our second spaceship, we will find bottlenecks in our production cycle. We will eliminate these and find the next bottlenecks, and so on. And soon, we're not struggling to build our second spaceship. We're looking, how many spaceships can we build per minute? So, why am I giving this talk? In March 2020, during the lockdown, and with nowhere to go outside, I had a lot of time at hand, and I started another game of Factorio. I spent about 150 hours on the game over 2 months, reading up resources, discussing architecture with a friend, and over time, I started to realize that a lot of the discussions we had and a lot of the patterns that we read up on or we discovered ourselves have pretty strong analogies in software development and software architecture. And at the same time, I was with a client at my job, a corporate startup, which was growing from very small, from 2 teams and 10 developers, to over 20 teams and over 100 developers over the course of 2 years. And with that growth comes all kinds of challenges. Scaling architecture, investing in automation, rearranging teams, dealing with legacy code, and dealing with operations. But even fast-changing software projects like this one change on a scale that seems pretty static. And it takes a long time to really observe the effect of any larger organizational or architectural change. So the beauty of this analogy is that in a computer game, everything moves a lot faster. So you also get feedback a lot for any change. You get a lot quicker. Basically, we can condense the evolution of a multi-year software project down to just a few weeks of gameplay. And this time-lapse view allows us to learn something. Now, before we dive into the main part, let's quickly have a look at how the main game mechanics of Factorio work. Just the bare minimum to understand what I'm going to be talking about. In Factorio, you have resources that you're going to turn into intermediate products and actual production items. One example for a resource is iron ore, which is mined from the planet's surface, and iron ore is turned into iron plates in a building called a furnace. And during the process, we consume a fuel, for example, coal. A very similar process exists for iron plates, which can be turned into steel plates, again in a furnace. And we have lots of other resources, like, for example, copper ore, stone, water, or crude oil. Now we can combine these resources and basic products in more advanced and complex products. For example, electronic circuits, which are created from copper wire and iron plates in a factory called an assembling machine. Copper wire is, of course, made from copper plates, which is in turn made from copper ore. And then there's an advanced version of circuits, which in turn take those green electronic circuits in order to produce, among other ingredients. So you have a very, very deep tree of resources. But in the end, this is just the tip of the iceberg. There are lots and lots of other intermediate products that we're not going into here. It's important to note that everything in Factorio is produced from these resources and intermediate products. So, for example, furnaces, which are buildings, but they are made from stones, and they are created in assembling machines. Even assembling machines themselves are made in assembling machines. Next to production, the other important ingredient in Factorio is logistics. There are different tiers of logistic networks. The most basic one are belts, inserters, and chests. Belts are great for moving items over short to medium distances, and inserters are kind of the adapters to the belt network. In order to feed items to a machine or chest, we use inserters to pick up the item and place it, and the same for placing the resulting products back onto a belt. The next tier are logistic robots. These robots can pick up items from a chest and move them to another chest where they are needed. Logistic robots are very flexible. They can produce anything from anywhere to anywhere, unlike belts, which have to be routed properly. But the robots have very low capacity. In addition to logistics robots, there's also construction robots that can construct buildings. These allow us to automate construction of new buildings. Rather than placing buildings by hand, we can just add a placeholder and let robots do the building work. And third and last in our logistics stack are railways. Those train wagons have very high capacity, but they need some time to be loaded and unloaded. So trains are best to move large amounts of items over large distances. The last thing to mention is how the tech tree is discovered in Factorio. In order to unlock new products or technologies, you need to do research. And this is done by producing science packs from other resources or products, which then are consumed in a science lab in order to research new technologies. Therefore, in order to advance in the game, you need to produce science packs, do research, and then you can start building new factories. Now, let's start with a new Factorio game on the green field. In the very beginning, as mentioned, we have nothing except for an axe, and we can use that in order to mine the very first resources. A few bits of coal, a few bits of ore, and a few bits of stone. We can use those stones in order to build a furnace, melt some iron with the help of coal, and that allows us to build the very first bits of actual infrastructure, like drills for mining, chests for storage, and inserters to connect these to our furnaces. But things really start to take off when we start using inserters and belts to wire up things. Previously, we needed to run from one resource patch to the other, for example, to carry coal to our furnaces. Now we can connect them with belts and transport the resources from where they are mined to where they are consumed. But if we do that in a naive way, just run a belt wherever we need the resource, it soon starts turning into a mess. So this is the point where we actually need to think about architecture. How do we properly design our Factorio base in a way that we don't end up in a mess when scaling? So what are the ingredients that we need for that? We want to be able to add new types of factories as we explore the tech tree. We want to be able to scale existing factories as we need more throughput, more resources. And we also want to funnel resources in a way that belts are not all over the place, but in some way well ordered. Luckily, we don't have to figure this out on our own. By now, there's a collection of architectural patterns for Factorio. So you can't just pick one and use it. This specific pattern here is called the bus. The name comes from, it looks similar to the bus on a main board. You have resources flowing north to south, factory clusters branching away east and west, taking the required resources from the bus and feeding the resulting products back into the bus. We can scale vertically by adding new factories at the end of the bus as we develop new technologies, and we can scale horizontally, growing the clusters to the side as we need more throughput. So this is very similar or analogous to the object-oriented monolith of Factorio bases. Everything is in one place, everything is well ordered and well connected, you have a clear separation of concerns. And the pattern actually is pretty good, it gets you a long way. It's pretty compact, it doesn't waste much space, and it's quite scalable. So what can we learn about software development here? First of all, the power of architectural patterns. When starting on the green field, things look very easy in the beginning and turn messy really quick. Having an understanding of architectural patterns is vital, and more importantly, a clear decision which approach to follow. It's not so much about choosing the very best pattern, because at some point this will be legacy code anyway. The important part is to decide for a structure and to stick to it. And in the very beginning, this structure can very well be monolithic. With a team of 3 people, you don't want to build 15 microservices. You'll be more caught up in context switches than producing actual working software. Same goes, for example, for Git repositories. At the beginning, a mono repository is virtually always a good idea. It fosters collaboration, keeps things cohesive, and if you need, you can still split it up later. So let's leave this bird's eye view for a bit and zoom in. As you've probably noticed, these little factory clusters that are branching away from the bus, they are quite repetitive. There actually goes some work into optimizing those little units. So to get the ratios right, for example, between copper wire and so factories that produce copper wire and factories that produce circuits here. So the ratios depend on production time, the amount of each resource needed, and we also want to gulf down space consumption. In the beginning of the game, we construct and place every single building manually. But over time, this becomes rather tedious, especially as clusters become more complex and such as this cluster that produces red circuits. So you have a very, very long production cycle from producing copper wire, green circuits, and then red circuits. So it's time to think of how to automate things. Factorio allows us to create blueprints of a group of buildings. So we can design our circuits factory once and then duplicate it over and over again. In fact, we don't even need to design it ourselves. There are websites where you can search for Factorio blueprints and import them in your game. Then construction robots come into play. They will carry the necessary resources to the building site and create the building according to the blueprint. For creating a building manually, the player needs to have the resources in their inventory and needs to be near the building site in order to place the building. With construction robots, we just place the blueprint somewhere, and that building site needs to be covered by the robot network. So, what is the lesson we can learn here? The first lesson is automate everything. Whenever we encounter a repetitive problem, then we should think about automating it. Build scripts, CI/CD pipelines, deployment. The benefit is not only that it is less work. In fact, sometimes automating things is even more work. The real benefit is that we don't need to remember the details anymore. If I'm the only person who knows how to deploy a service and I'm on vacation, that's bad. But if deployment is just a step in an automated pipeline, then anyone can do it and I can enjoy my holiday. The second lesson that we can learn from Factorio here is the power of templates. There are some repetitive tasks that are either impossible to automate or just not worth the effort. In these cases, templates can still come in handy. For example, setting up a new repository for a new service. If we do that every few months, then it's not worth automating it. But having a template for the repository structure and for the most common tooling, that can be very valuable. And the next team who can just copy-paste the template and start from there might thank us. And also look for existing templates. Many frameworks provide a command line interface or some bootstrap script for bootstrapping new projects that might be a bit opinionated and might not fit the exact conventions or purposes that we have, but it's often a good starting point. Now, let's zoom out again and have a look at a larger bus base. At some point, even with this design, even with this architecture, we are going to run into scaling issues. All in all, the architecture is too monolithic and too inflexible. There are certain limits to the width of the bus, and eventually we will also run into obstacles like rocks or the sea, so we can't just scale that indefinitely. Also, the pattern of feeding resources at the very top only works as long as we have enough resources in that area. At some point, those resource patches will be drained, we will run out of resources, and we need to fetch them from farther away. So, it is time to change our architecture. And for that, we need a new logistics paradigm. With belts, we had to build everything very compact, since belts are expensive, slow, and limited in throughput. So all that favors a monolithic architecture. The solution we are looking for in Factorio is railways. These solve virtually all of our belts problems. Rails are cheap, trains are fast, and they have high capacity. But railways do have some downsides. Unloading a train requires quite a lot of time, and the train station takes up quite a lot of space. So trains are not the silver bullet for every transportation issue. They are a specific tool for long-distance transport. So let's see how this allows us to change our architecture. We can now break up our monolith and create new small spin-offs for our base. But unlike our main bus base, they are specialized to do one specific thing. This one, for example, mines iron ore, immediately melts it into iron plates, and then loads everything on a train. In our main base, we replace the former mining and melting cluster with a train station that fetches iron plates from the external cluster and feeds it into the existing bus. In fact, we don't even need to care where exactly the iron comes from. It could be any of potentially multiple spin-off bases, multiple providers. Now, we have replaced a part of our monolith with a client that fetches resources from an external entity. That sounds a bit familiar, doesn't it? So, we've essentially invented microservices in Factorio. The analogy is actually quite striking. The concept of microservices builds upon common protocols and formats for long-distance data transfer, HTTP and JSON, which is kind of analogous to our trains. The marshalling and unmarshalling between domain objects and JSON just corresponds to our train loading and unloading stations. And microservices are designed to do one specific task, just as our microfactory is designed to produce a specific resource. As a result, we generally decrease the complexity of our architecture. It becomes less necessary to have the full overview over the system. Instead, it's possible to work on specialized parts of the system independently. So when growing from one or two teams to multiple teams, this shift allows us to break up complexity into small, manageable parts. The downside of this shift is that managing infrastructure becomes more complex and more important. In Factorio, more and more effort goes into planning and maintaining the train network itself. In software architecture, more and more effort goes into infrastructure and operations on monitoring, often leading to dedicated SRE teams. Just as we said, trains are not the silver bullet, the same holds for a microservice architecture. Just blindly splitting things into smaller and smaller units creates a lot of infrastructural overhead. So it's good to put some thought into how small our units really should be. Now, with our shift towards microservices, we overcame the inherent expansion limits of the bus architecture. So we were able to scale a lot easier. However, even with this new architectural paradigm, still there is quite a lot of planning and decision-making involved. In order to extend our base, we don't need to refactor as much as before, but it still involves a lot of manual steps. We need to look for a good spot where we can build our small independent microfactory. That is something we need to do manually. Then we can build the manufacturing cluster from a blueprint. That's somewhat automated, but connecting it to the train network still involves routing belts and train lines manually. And then we also need to connect the new factory to the existing train network without breaking anything else. All in all, by routing train lines just wherever we need them, we run into the same problems as with belts, as with routing belts wherever we need them. At some point, it will turn into a mess. So wouldn't it be nice if we could just scale? If we could add more factories without having to worry about where to add them exactly, with the railway connection already built in, and all that in a way that is tidy and does not turn into a mess. So it turns out there is a pretty neat pattern. There are two ingredients to that pattern. One is a predictable grid layout. This layout can be constructed from a single blueprint. It tiles very easily, and the train connection is built in. Trains just move along the edges of that grid. The second ingredient is a Factorio mod called the Logistic Train Network. This mod allows us to mark train stations as sources or sinks, producers or consumers for certain products. And it will automatically dispatch trains from wherever they are needed. So when you need coal somewhere, then a train will be dispatched to a coal source, will transport coal to the destination. So our plain grid cells look like this. Effectively, this layout allows us to completely decentralize architecture. Instead of planning a new train line, we just add cells wherever we want, and it just works. Now, let's add some content to those cells. Each grid cell has train stations built in for consuming and producing certain materials or products. For example, the cell here on the left consumes iron ore at the top and produces iron plates at the bottom. The right one looks almost exactly the same, but it turns iron plates into steel plates. One neat little detail, I even added monitoring to those cells. So you can see that the input buffer here is starting to run empty, but the output buffer is almost full. Each cell is a little factory on its own. It will take some time to design, to get the balancing right, to route the belts properly in the most space-efficient way. But then it can be blueprinted indefinitely. And if you want a new and improved version of a cell, then you can just replace the old cells with the new ones. So these two cells here, for example, both produce the same thing. They both consume iron plates and copper wire and produce electronic circuits. The left one is an older version, while the right one is the new, improved, and more efficient version. If we are running low on a particular item, we can just add another cell that produces the item. Because of the grid layout, it doesn't matter where exactly we deploy that new cell. We can just build it somewhere where there's free space. The result is this very uniform and decentralized grid, which covers an area almost 20 times as large, so this is to scale, 20 times as large compared to our bus base. Now, what is it that we are actually building here? We've basically switched to service-oriented architecture. Our automated train logistics network is basically a service mesh. And, well, it looks like a mesh, right? Our self-sufficient factories have an analogy in containerized microservices or Kubernetes pods. So, why was this architecture switch essential for us being able to scale? We can scale individual parts of our base without having to change the overall architecture. Just think how we would have had to resize the bus in order horizontally to allow more throughput or vertically to make more space for new factories. Here, adding a new factory changes, let's say here, adding a new factory changes nothing to the overall architecture. Cells can be created, modified, replaced completely independently. If we were to play this in multiplayer, each person or team could be responsible for one cell type, and nobody would need to coordinate the overall layout. This means that also the role of a software architect changes. In a monolithic architecture, like our bus base, the role of an architect is to oversee that everything is in its place, and to decide where exactly to add new stuff or how to refactor, so that the overall architecture stays well ordered. So an architect needs to be closely involved with every decision a team makes. In service-oriented architecture, like our Factorio grid, the role is very different. Software architects are rather responsible for the overall framework, like the grid itself. But teams can be much more independent in making decisions as long as they are staying in that framework. So by that point in the game, of course, most of these analogies had already started to dawn on me, right? So I thought to myself, why not reverse the thing? Why not play around with those analogies and use patterns from software architecture in Factorio? So we've cycled through multiple architectural paradigms, from monolith to microservices, but we haven't tried serverless architecture yet. When stripping things down, what do we really need in order to produce something in Factorio? We just need a single Factorio building, like an assembling machine, and some adapter to some kind of logistic network. The most flexible network are logistic robots. So what would the very minimum production unit look like? It is really, really compact. Just a single assembly machine, a few chests for input-output, and the logistic robots take over all the rest. So this minimum unit also looks very scalable, right? And it tiles really well. So just like with our train grid, we can just add new factories anywhere, just wherever we need them. But since the units are much smaller, we are even more flexible, right? Well, here's the lesson that Factorio taught me. It doesn't scale well. The smaller the units, the more overhead we have per unit. So we run into performance limits much sooner. In the case of Factorio, the limit is CPU power, actually. The smaller the unit, the more overhead the game has for scheduling and moving the items, essentially planning the way for those logistic robots. So scheduling thousands of robots, just moving a few individual items each, is way more scheduling overhead than scheduling a single train with thousands of items. Factorio usually has 60 game ticks per second, and I was soon down below 10. So the game was still running, kudos to the Factorio developers, but not at a playable speed. On the other hand, this result from Factorio is actually pretty consistent with real-life experience, or at least my personal real-life experience with serverless architecture. While serverless is great for scaling small projects from zero, because you don't need to invest into infrastructure and only pay for what you actually use, we don't get any benefit on large scales. Sure, it scales linearly, but with a very bad factor. There are still some places where serverless can shine, though. for infrequent or low throughput tasks and tasks that are not time critical. Here, the approach really makes sense. And there's again the analogy to Factorio. There are some products that we don't need on a train load scale. For example, assembling machines themselves. We need a few thousand of those assembling machines in total in our game. So this is very small compared to a single train load. Plus, they will be built by construction robots in the end anyway, so it makes sense to store them already in our robot network. So for producing assembling machines, the serverless pattern really makes sense, and similar for most type of buildings. So you have this cell here that's essentially a cluster of serverless factories that produce the resources that we don't need very frequently. Well, and this is what software architecture taught me about Factorio. Let's take a step back and look at what we've learned. So I just gave you a roughly half-hour walk through a game of a Factorio. In reality, this was about 150 hours of playing time stretched over 2 months. But the development we saw somewhat resembles the growth and change of a software project over several years. So this brings me to my key takeaway. As a software project evolves and grows, so does its architecture, and also so do the best practices that we follow. In a small project with just 1 or 2 teams, probably on the green field, possibly with pressure to ship anything at all, we have a very different focus and will follow very different best practices than with a mature project. Hundreds of developers, possibly fighting with legacy code and pressure to make existing customers happy. In a lot of cases, there is no simple A is better than B, but the question is rather, what is the situation you are in? What are your challenges right now? For example, there are a lot of opinions around on why mono-repositories are better than separate multiple repositories, or vice versa. And by looking at the time component, my answer is it really depends. Are you just starting a new project on the green field with 1 or 2 teams? Then you probably want a mono-repository. It fosters collaboration and exchange, which can greatly help focusing on the few features that it takes to make up a minimum viable product. But when you have 20 teams to juggle, each with their own domain and their own responsibility, you want to minimize the synchronization overhead needed between those teams. So you will probably rather want strong separation of concerns and therefore separate repositories. And a similar argument goes for monolithic versus microservices, micro front ends, and the like. This marks the end of my talk, so thank you all for listening. I hope that you found this talk both entertaining and instructive, just as I found playing Factorio both entertaining and instructive. And I think we still have some time left for questions. Thank you.
So first, thank you for a great talk. And indeed, we have some time for questions. And I already saw some hands raised. So I'll start with the first hand I saw.
Hi, thank you for the presentation. How do you think Google works with a one big monorepo?
Sorry, can you repeat?
Yeah, Google with one big monorepo. How do you think that works?
I have honestly no idea, and I would really like to see that in action. But I think what they have is quite a lot of tooling around it. So they're not following the default Git approach, right? So they shaped their organization and their tooling around that approach. So it is not something that you can simply adapt or adopt like, yeah, we're just doing the same thing as Google does, because you're probably not going to do the same thing as Google. You're just going to go the naive way and have a single Git repository. But Google put a ton of work into making this work.
Thank you.
Let's continue with the next question.
Thank you for the talk. The comparisons were really amusing. I have 2 questions. The first one is, I assume in Factorio, transitioning from one architecture to the next is not that time consuming as opposed to real life. So how, in a real project, when you transition from 2 teams to 20, I mean, this usually takes a massive amount of effort. And then again, to go like serverless, for example. If you already know that your project is going to be very big, do you think it would be worth it to already try to get ahead?
You have to find the right point in time. So if you already start with the structure of a huge project or huge company, then you have the initial, so initially you don't have very many people, so you have already a lot of overhead that can't be serviced by few people. So you have to start with lean structures and then find the right point in time to scale your structures. And finding that right point in time is really, really hard. So in Factorio, if you don't have trains from the start, you have to discover that. But if you wait too long with switching from a bus layout to a train layout, then you start running belts over very long distances and you're just stuck. If you start switching too early, then then building your train network takes a massive amount of time because you don't have the throughput yet that it's required in order to build long train lines. So, and yeah, in reality, in software development, you have to find the right point where you have the necessary number of teams that you can actually distribute the load across. But at the same time, you shouldn't wait too long so that responsibilities start to diverge, or you have a monolith that 20 teams are working on and just stepping on each other's feet. So I've seen this in a project, especially as with the organizational shift from domain teams towards product teams with end-to-end responsibility. And that took some time. That really took some time to implement. And probably the shift was a bit on the late side. And yeah, it takes half a year or even longer to really reap the benefits of that change.
Okay, thank you. And the second question is, have you tried or heard of, I think it's called Satisfactory? It's a very Factorio-like game. Just in case you want content for next year's talk.
Yeah, so I'm a rather addictive person, and I've been clean for 4 years now. I won't start another game of Factorio.
So the next question comes from the back.
Hey, quick question. In Factorio, there's also enemies who want to destroy your factory. Do you have an analogy for that?
So I've never played with enemies. It's a lot less fun, I think, because the fun is really in optimizing and making things work. But I mean, you probably can imagine the analogy, right? From the perspective of a software developer.
So I think it's time for one last question here, and I go to the center of the room.
I'm sure I'm not the only one thinking this, but given the 3 different styles, what was your throughput rockets per minute?
I don't remember exactly, but I think it was around 2 rockets per minute.
So thank you again for the great talk and your awesome questions. And that's it. Have a nice break.